All right, welcome back. In this video, we're going to do Module 3, Topic 7, Parallel Lines and Transversals. The standard for this topic is GR 1.1. That's prove relationships and theorems about lines and angles, solve mathematical and real-world problems involving postulates, relationships, and theorems of lines and angles. The objective for this lesson, you guys are going to identify and use relationships between parallel lines and transversals. And the essential question is, how do parallel lines affect the relationships between special angle pairs? We got the bell ringer. We're on page 1, week 7 packet. I want you to pause here, work the bell ringer, and then we'll work together. See how you did. All right, bell ringer number 1. Find the missing angle measures. If you guys will look, these 4 angles are created by these 2 lines intersecting, so we have vertical angles. Okay, and vertical angles, these guys left and right of each other are sitting side by side. Those guys are congruent. And then the 2 on top of each other. So the one on top and the one on the bottom, those guys are congruent to each other. So if they're congruent to each other, so if this guy over here is 5x, let's see if we can zoom in just a little better. So this one over here is 5x. That's going to make angle 1 right across of it also 5x. This angle up here is 13x, so angle 2 is also going to be 13x. Okay. All right, number 2. Use the figure to name the angle pairs. All right, so our vertical angles, those are going to be, and actually to start this, I'm going to draw these lines in different colors so we can make it a little easier to differentiate for our linear pair for the third question. So let me make these letters a little bigger. That's MX. That's an H up here, and that's a T. So our vertical angles, that's going to be this angle and this angle together. So that's going to be angle MXA and angle HXT. All right, so we also have the top one, that's MXH, so angle MXH. And then lastly, angle AXT. So angle AXT. So those are there's your 2 pair of vertical angles. All right, so number 3 here asks about the linear pair. And this is where the 2 colors comes in. Borrow my vocabulary from the other day. All right, so if we cover up the line here, we can see our linear pair. So because they both make, this line is 180 degrees, so these 2 angles together make 180. We would do that over here for these 2. So you notice the green line, it's this XH here splits this, so this is 180. These are supplementary, so they're a linear pair. We flip, so we did the blue, we did the green, then you do this side of the blue, and then you do that side of the green. So let's start here. We have AXM, and then the other side of it is MXH. Do these in different colors. All right, so if we're looking at this line, this linear pair, we have MXH. And you see these are going to, because they start here, so the second one of each of these pairs is going to be the first one of the next. So we got MXH and then HXT. Okay. Now if we go this way, let's see, hold on, which way did I stop? I went here, we started here, and then we went here. Now we go here. So we start with, as I said, the last of the pair here is the first on the next 2. So HXT, and then TXA. Then we've got our last set of linear pair. Let me find one other color. Excuse me a moment. All right, so here we have TXA again. And then lastly, AXM, which is where we started from. We went all the way around. All right, let's adjust our paper. Scooch up to the guided notes. Again, still page 1, about halfway down. Let me write these in real quick for you. Okay, so if two lines do not intersect, then they are either parallel or skew. Parallel lines are coplanar, so they're on the same plane, and they do not intersect. Our example over here is JK and LM. Notice this symbol, that means these are parallel. Notice they are the same distance apart, but they're on the same plane. All right, skew lines. These are lines that do not intersect. They're non-coplanar. So we have over here line L and line M, but this is on plane A, this is on plane B. So skew lines are non-coplanar, and that's the reason they will never touch. Okay, just below. 1 second. All right. A line that intersects two or more lines in a plane at different points is called a transversal. In the diagram below, so right here, line T, we'll make it red since we wrote transversal in red. So T's are transversal. It's transversal of lines L and M. Line T forms a total of 8 angles with lines L and M. So you see 1, 2, 3, 4, 5, 6, 7, 8 down here. These angles and specific pairings of angles are given special names. What do you notice about the image to the right? So we're going to zoom in a little. So notice we're 120 on the top left, we're 120 on the bottom right. So these guys are congruent. We're 60 over here and 60 over here, so these guys are congruent. Notice that these two angles are created by the line splitting the straight line. That should be 180. 120 plus 60 equals 180. Over here, 120 plus 60 equals 180. See, 60 plus 120 equals 180, and 120 plus 60 equals 180. We look down here, notice 60 again, so these are congruent to each other, but they're also congruent to these guys. And our 120. So, the pattern here, let's zoom out. What do we notice is that opposite angles are congruent. I want to take this time to mention congruent and equals is the same thing. Just trying to get you guys to see that. 1 second. Okay. All right, so yes, our opposite angles are congruent. We also, this is green. Keep these pencils from falling. So our adjacent consecutive angles are supplementary. Sorry, go a little. All right, so these angles are supplementary. Okay, just a moment. Flip over to page 2. Talk about these angles. A little better. Let's zoom in just a hair. Okay. Okay, so alternate interior is what we're going to start with. Now, when we're talking about interior, we mean inside lines L and M here. So give me just a moment. Let me get set up. I'm getting ahead of myself. All right, so notice we've shaded in between lines L and M. Alternate interior angles are non-adjacent interior angles that lie on opposite sides of transversal T. So in this case, so interior again means between the two lines that we're talking about being parallel. And so they're on non-adjacent, so they're not next to each other, and they lie on opposite sides. So we would have 3 and 6 would be alternate interior, and 4 and 5 would be. So there are 4 of these if L is parallel to M. That's okay. Let's see. Okay, let's see here. All right, so consecutive interior angles are interior angles, so inside L and M, that lie on the same side of transversal T. So in this case, 4 and 6, they're right across from each other. 3 and 5. There are 4 of these if L is parallel to M. Now, consecutive interior, and it doesn't tell you this, but these guys they equal 180. The alternate interior, those are congruent. Now, we'll learn that later, but I figured out doing the lesson that I need to tell you guys that along the way. So consecutive interior equal 180, the supplementary, and the alternate interior are congruent. So let's move over. Continue on. Give you the next type of angle. All right, so this one says alternate exterior. So exterior is going to mean on the outside of the lines. So lines L and M still, but we're talking about the exterior or the outside. Alternate exterior angles are non-adjacent exterior angles that lie on opposite sides of transversal T. So opposite sides, so 1 and 8, 2 and 7. So we have 4 of these if L is parallel to M. Scooch over here. All right, same side exterior. Let me just color this in. So again, exterior is going to be the outside of the lines. And it says same side. Well, that's going to be, you can either say 1 and 2 or 1 and 7. We're going to go across just so we're, so 1 and 7. 2 and 8. So 4. There we go. Let's go back over here. This is our last angle. Shout out to fourth block for letting me know in class that I misspelled corresponding and then giving me a hard time when I didn't stop and correct it. So I'm correcting it for you guys right now. So corresponding angles lie on the same side of the transversal T and on the same side of lines L and M. Now we have a little typo here. It should be L and M. That's what we've been dealing with. That's the same lines. So corresponding means so they're in the same spot. Let's see. So like here, 1 is in the top left. 5 is on the top left. Say if we if we're looking here and here, so on this group of angles, 1 was on the top left. On this group, 5 was on the top left. So still looking the same way. 2, top right. 6, top right. 3, bottom left. 7, bottom left. And then lastly, 4 is the bottom right. 8 is also the bottom right. There are 8 of these corresponding if these guys are congruent. And corresponding angles, let's see, let me go back here just a moment. So alternate interior and exterior angles are congruent, just like the interior, and same side exterior, they're going to be supplementary or equal to 180. Corresponding, they are congruent. Okay, let's back up just a little. All right, still on page 2, number 1. Are lines L and M parallel lines? Why or why not? All right, so let me zoom in. All right, so in order for these guys to be parallel, just like from the previous page, these angles have to be congruent. So you see 135 and 135, so those are congruent. So far so good. 45 and 45, okay, cool. And then if you look, 135 and 45, that equals 180. So this checks out up here. The problem we're running into is down here. We have 137. So because this and these are not congruent, these guys are not parallel. Notice that this angle here and this one, those are both inside lines L and M. So those are alternate interior angles, and those should be congruent, and they're not. So it's no, and it's because alternate interior, this is the symbol for angles, are not, running out of space, congruent. Okay. Same thing here. These are not either. All right, number 2. Given the two lines A and B, so this line and this line, are parallel, so they're telling us they're parallel. Cut by transversal T, so here's this transversal. Fill in the missing angle measurements. All right, so in order for these two lines to be parallel, let's use a different color. Hold on. So this guy is going to have to be congruent to this guy, and this guy will be the same as those. And then these angles will be congruent. Okay, so, and then remember, each linear pair is going to be worth 180. So this guy is going to be 180 minus 23.5. So it's going to be 156.5. So that's going to make this 156.5 and these two. This is 23.5. This is 23.5. I'm not going to write that again because these are all the same, but because they're congruent. Hang on, I think I miswrote that, dang it. Yes, I did. Well, this one is 23.5. See, this is what happens when you get too much stuff. So, I'm trying to write it in. That was 23, that was 156.5, 156.5. 23.5, and then this one's 23.5 because this goes to that. All right, we got an I do here at the bottom of page 2. It says that the measure of angle 3 is 4x plus 7, and the measure of angle 6 is 5x minus 13. Find the value of x. All right, so first thing I like to do, I'm going to highlight these. So since we're talking about angle 3 and angle 6, I'm going to make them orange. So angle 3 and angle 6. All right, so notice the little symbol here, this arrow, not the arrow at the end, but this other arrow. That means that these lines are parallel. So in order for them to be parallel, we're talking about in between the lines. So this is the interior. Notice these are alternate interior. So these would be equal. So first we're going to name these guys, and they're alternate interior. And so to find the value of x, the measure of angle 3 is going to be equal to or congruent to the measure of angle 6. So we're just going to substitute. So 4x plus 7 is going to be equal to 5x minus 13. Some different colors. So now we're just going to solve for x. We're going to subtract the 4x from both sides. Those cancel. 7 comes down. 5 minus 4x is x minus 13. Add 13. Add 13. X is going to be equal to 20. Pencil problems this evening. So x is equal to 20. Okay, let's scoot this over. All right, number 4. This is a you do. Please pause the video. Try to work this yourself. I'm going to wait 3 seconds before continuing. Unpause once you're done. Let's see how you do. All right, number 4. Find the value of y if the measure of angle 4 is 68 degrees and the measure of angle 6 is 3y minus 2. So first thing I'm going to do is mark these angles. So we're going to call 4 and 6. We're going to make them both blue this time. So J and K are parallel. This is inside, so it's interior. And these are right across from each other, so they're consecutive. So consecutive interior. And what do we know about consecutive interior? We know that they are supplementary, which means they're equal to 180. For the next little while, we're going to do this. I'm hoping you guys are going to, this stuff will start sinking in. So in order to solve for y, we're going to put both of these angles equal to 180. So measure of angle 4 plus measure of angle 6 is equal to 180. Substitute. So measure of angle 4 is 68. The measure of angle 6 is 3y minus 2. So I'm going to combine steps here. 68 minus 2 is 66. 3y comes down. 180 comes down. Try not to run out of space. Yeah, let's see. Okay. So 66 from both sides. That's going to give us 114. 3y, divide both sides by 3. Then come up here, and y is going to be equal to 38. Okay. Hope you got the same thing. All right, let's flip over to page 3. Okay, I'm going to bounce out just a little so we actually, a little more. I want you to be able to see the whole proof and the word bank. Give me just a second to adjust. I apologize. Okay, left side, page 3. Number 5. We've got a proof given that measure of the angle 8 is 26 degrees. We're going to prove that angle 2 is 154. So we're dealing with angle 8 and angle 2. Notice these are both outside of JK. So these are, I'm just making a mental note that these are same side exterior. And so just so I know before we get started here, sometimes you mark these things as you go. It'll really help you with the proof as you're going with it. So the first statement is the measure of angle 8 is 26 degrees. First, I'm going to put 26 degrees there. That was given. So it's given. Next, they say that the measure of angle 8 is congruent to the measure of angle 4. Let's just, so they're saying 8 and 4 are congruent. Well, notice 4 is bottom right, 8 is bottom right. So what do we know? We know they're corresponding angles then. And I'm going to abbreviate angles because we're running out of space here. So corresponding angles. All right, number 3 says that the measure of angle 8 is equal to the measure of angle 4. So we went from 8 is congruent to 4 to 8 is equal to 4. When we change from equal to congruence, congruence mean equals and congruence mean the same thing. So that's the definition of congruence. Okay, definition of congruence. Okay. All right, so we go from 8 equals 4 to 4 equals 26. Notice they gave us at the beginning that 8 was equal to 26. So all we're doing is substituting 8 for 26. So that's a if I could write, substitution. Okay. And next we have that measure of angle 4 plus the measure of angle 2 equals 180. Well, notice that 4 and 2 are on this line, so that's a linear pair. So we're going to use the linear pair theorem to say that this is true. Now leave me alone about my terrible writing. Okay, so we go from 4 plus 2 equals 180 to 26 plus 2 equals 180. Well, up here, see, we're substituting 4 for 26, so substitution. So our second substitution. All right, and then lastly, m equals 154. Well, if you subtract 26 from 180, you get 154. So the answer to this is subtraction. The subtraction property of equality, we're just going to say subtraction prop right there. Okay, number 5. Please pause the video right here. Try to work this proof yourself. I'm going to wait 3 seconds and continue. Actually, I'm going to take a longer than 3 seconds because I'm trying to find a pen that writes better than these colored pencils. Okay, I give up. Colored pencils it is. All right, number 5. Given that the measure of angle 6, so we're dealing with 6, and we're going to prove that 1 equals 40. So we're dealing with JK. So alternate interior. And it's angles, but we're out of space. All right, so we go from 3 is congruent to 6 to 3 is equal to 6. Hope you're catching on. That's the definition of congruence. Given definition of congruence. Okay. All right. Statement number 4. Measure of angle 3 is equal to 120. So let's just write that up here in black. 120. So let's see. Well, they told us that 6 was 120. They told us that 3 and 6 were congruent. So all we're doing is substituting 6 for 120. So that's a substitution. Sorry. There we go. Okay. All right, next we have the measure of angle 1 plus the measure of angle, measure of angle 3 plus the measure of angle 1 equal 180. So 3 and 1 are 180. Well, they are a linear pair. So that's the linear pair theorem that tells us that. All right, we're off the page there. All right, next statement. We go from measure of angle 3 plus 1 equals 180 to the measure of angle, that we go to 120 plus the measure of angle 1 equals 180. So we substituted the measure of angle 3 for 120. So that's substitution. All right, then lastly, the measure of angle 1 equals 40. Well, if we subtract 120 from 180, we get 40. So that is subtraction again. Okay, scooting down to the bottom of page 3. I believe, yeah, this is it. So this will finish off the lesson. Number 7 is the I do. And number 7, the other one, is the you do. So the first number 7 to the left, we're given that the measure of angle 5 is equal to the measure of angle 4. So let's just mark our angles here. And they are congruent, so we can do those. So 5 and 4, notice that these are inside L and M, and they're alternate sides, so that's alternate interior, okay? Just something to note before we even look at everything. All right, statement 1, 5 is equal to 4. That's the given. All right, next we have that 5 is congruent to 4. Well, please tell me you said definition of congruence. I hope so. All right, and lastly, lines L and M are parallel, and it's because these guys are alternate interior. So we've kind of set ourselves up. If you look at those angles prior to messing with your proof, you can kind of have an idea of what you're going to be looking at. All right, number 7 is the other number 7 is a you do. I'm going to stop here, pause 3 seconds. You pause the video, try to do this, and then see how you do. All right, number 7, part 2 here. Bottom of page 3, end of this lesson. So we're given that 3 and 7 are congruent. Just say 3 is congruent to 7. All right, well, I noticed that 3 is my bottom left, 7 is bottom left, so they're corresponding. That's going to come into play. All right, so given 3 is equal to measure of angle 3 is equal to measure of angle 7. All right, 3 is congruent to 7. Well, first it was equal, and then it was congruent. We pretty much said the same thing because that is the definition of congruence. All right, and then lastly, lines L and M are parallel. And why are they parallel? Because those guys are corresponding angles. We're going to abbreviate corresponding angles. All right, guys, this is the end of topic 7. If you have any questions, please let me know, and have a good night.